later. So again, the octet rule states that every atom tends to have 8 electrons in the outermost energy level, in the last energy level. That's the octet rule. Of course, it has some exceptions. For the small atoms, such as hydrogen, helium, lithium, beryllium, boron, they are so small that they cannot hold 8 electrons. They have only 2 energy levels. The second one only have sublevel S. So they, instead of getting or achieving the octet rule, which is having 8 electrons in the last energy level, they achieve the duet rule. That means they will tend to have 2 electrons in the last energy level. So let me give you one example here about the octet rule first, and then later I will show you about the duet rule. If we have chlorine that has 7 valence electrons, and we also have sodium, can anybody tell me how many valence electrons sodium has? Anyone? Can anyone tell me? Hola. Hello? Is anybody listening?
One.
Okay, thank you, Chastity. That is correct. Sodium has only 1 valence electron. So let me explain this to you quickly. If these two guys meet, this is what is going to happen. Everybody here wants to have 8 valence electrons or 8 electrons in the outermost energy level. I'm going to do not only the Lewis structure for sodium, but I'm also going to do the Bohr structure for it, which is type in the symbol of the element, and then around it, I'm gonna put the energy levels and the electrons that they have in every energy level. So sodium has 3 energy levels. Nope, I don't like that one. Let me do it again. Yes, this one looks much nicer. All right, so sodium has 2 in the first energy level. It has 8 in the second energy level. For those that might be lost, let me just do the electron configuration for sodium here. 1s2, 2s2, P6, and 3s1. Sodium is number 11, right? Okay, so we have 2 in the first energy level, and now we're going to have 8 in the second energy level. 2, 3, 4, 5, 6, 7. No, that's 8. That's 8. And only 1 in the last energy level. Am I correct? Let me see if this is what we need to have here. We have 2 in the first energy level. In the second one, I have 1, 2, 3, 4, 5, 6, 7, 8. Yes. And 1 in the last energy level. Now, please look at this. Don't blink, because if you blink, you might find yourself lost. When these two guys meet, this is chlorine with 7 valence electrons and sodium with 1 valence electron. When they meet, sodium is going to give its electron to chlorine. And now chlorine is going to have 8 valence electrons in the outermost energy level. 7 that are naturally its belonging, and 1 that was given, that was donated by sodium, right? When this happens, now sodium is left with no electron here. So that means this electron disappears. Did you see what I just did? Sodium donates this electron to chlorine, so it's no longer in sodium anymore. So this sodium disappears. And if I represent that in the Bohr structure, that this electron is the one that sodium donates. It's valence electron. And with this, I want to mention something very important. The valence electrons are the ones involved in the chemical bonds, because by the way, this creates a chemical bond that we know as ionic bond. I'll explain that. But before, let me explain something. Sodium and chlorine, both of them want to achieve, they both want to achieve the octet rule, this here. Chlorine achieved it because it has 8 electrons now in the outermost energy level. But how about sodium? Did sodium achieve the octet rule? Is it accomplished? Does it have 8 electrons in the outermost energy level now? The answer is yes. If you look at this, this is no longer the last energy level. This is just empty space. So this energy level disappears when sodium donates its electron to chlorine. And this, and this is the outermost energy level now for sodium. So how many electrons does sodium have in this energy level? Can anybody tell me? Hola.
Repeat your question.
The question is, how many electrons sodium has here in its current outermost energy level? 8. That's exactly what octet rule says, that atoms tend to have 8 electrons in the outermost energy level. So here, the relationship that we are seeing here between chlorine and sodium is not that chlorine is stealing this electron for sodium. It's not that it's robbing this electron from sodium. It's not taking it forcefully. They both have this tendency. Sodium wanted to give this electron away. Sodium wanted to donate this electron, and chlorine needed this electron to be given to it. So this relationship is good for both of them, because by doing this, chlorine now has 8 electrons in the outermost energy level, and sodium now keeps the second energy level as the one that is the outermost. And here, sodium has 8 electrons. So this electron that you have in the third energy level disappeared. And this now becomes the last energy level for sodium, where it has 8 electrons. Before I move on, is there any questions on this matter? Is there any question on this matter? Are there any questions on this matter? Anything that you didn't understand that you want me to go over, or everything is clear?
I think everything is clear for me.
Okay, perfect. Before I go a little deeper into this, I'm going to do another example for the duet rule, which is basically the same thing. But now the small atoms don't achieve 8 electrons in the outermost energy level, but 2. That's why it's called duet. And we have, for example, lithium. Lithium has 1 valence electron. And then hydrogen also has 1. Let me draw hydrogen in red. Hydrogen has 1 valence electron as well. Let me explain something to you. Before I do this, let me draw the Bohr structure for lithium. Lithium has, and let me do the electron configuration for it. 1s2, 2s1. Remember that lithium has only 3 total electrons. I equals 3. Let me put this to the side so that you can see the rest. So if I do the Bohr structure for lithium, I draw the ring around it. And then it's 2 rings. two energy levels. So 1 and 2. And then here it has, in the first energy level, which is the first ring, it has 2 electrons, 1 and 2. And in the third energy level, it has 1. I'm sorry, in the second energy level, it has 1. Now notice what happens between lithium and hydrogen. Lithium now is going to donate this electron to, oops, that's not what I meant. Lithium now is going to donate this electron to hydrogen. And when that happens, now hydrogen is going to have 2 electrons. Now hydrogen has 2 electrons here in the outermost energy level. Lithium gives that electron away, exactly the same thing that, exactly the same thing that sodium did up there. So now this electron disappears because it goes to hydrogen. So this, the last electron that we have here, the electron in the second energy level, this in the second ring disappears. And now the first energy level becomes the outermost. And for hydrogen, we'll also have 2. So these 2 elements that are very small, they achieve the stability because they actually want to have 8 electrons because they are stable when they have 8 electrons. They don't react anymore. And in the universe, everything tends to be stable in equilibrium. The chlorine is in equilibrium when it reaches 8 electrons, and all the atoms, except by the small ones that reach the equilibrium when they have 2. And again, these are the elements that go from 1 to 5. Hydrogen, helium, lithium, beryllium, and boron. They all achieve the duet rule and not the octet rule. Let me ask, what is the octet rule again? What is that? What does this rule say?
Something would go ahead.
No, go on.
Nah.
What does the octet rule say?
It says that an element wants to have 8 electrons in its outermost level.
That's correct. How about the duet rule? What does it say?
You get have 2 in the outer. Well, I forget the
In
word.
order to achieve stability, 2 electrons, the outermost shell needs to have 2 electrons.
That
For the
is correct.
smaller.
For the small elements, that's correct. From 1 to 5. Okay, now that this part is understood, I'm going to dig a little deeper into this. This type of phenomenon, this type of process produces a chemical bond because now the sodium and the chlorine bind together. Lithium and hydrogen now bind together. And this type of bond is what we know as ionic bond. And I'm going to type it here. Ionic bond. It's called ionic because it forms ions. And let me explain what is an ion. An ion, I-O-N, is an atom that has a charge. Is an atom that has a charge. When they are in neutral state, when the chlorine was all by itself with only 7 valence electrons, it was electrically stable or neutral because it had the same number of protons, positive charges, and electrons, negative charges. It had 17 protons and 17 electrons. The same thing I have to say about sodium. Sodium, before this bonding happened, had 11 protons, that's its atomic number, and 11 electrons. So it was electrically neutral. It was a neutral atom. Now, sodium has a charge, and chlorine also has a charge because chlorine doesn't have 17 electrons anymore. How many electrons chlorine has now?
18.
Now it has 18. About sodium, how many electrons sodium has now? If it gives,
10.
it has 10. Okay, so this is what we do to represent that sodium has received, I'm sorry, that chlorine has received 1 electron. We write the element Cl, and then we put a negative sign. The charge for chlorine is -1, okay? Because it has 1 extra electron, 1 extra negative charge. And that's why it's -1 or just negative. But the charge for sodium now is Na +1. And I need you to pay special attention to this, okay? Please pay attention to this. Sodium is the one that becomes positive, even though chlorine is the one that is adding something to it. But remember, this particle that you are adding to the chlorine is a negative particle, and that's why it becomes negative. Now, the particle that sodium gave away, which is the one received by chlorine, it was a negative particle. That means sodium now will have 1 extra positive particle, because at first sodium had, and I'm gonna type it here, sodium had 11 protons and 11 electrons. Okay, now when you took 1 electron away, you're gonna have only 10 electrons. In total, you will have 1 proton. So the protons now will have dominance in the sodium because you have 1 proton above the number of electrons that you have. Is that understood? Is that clear? Do you understand why the sodium is positive and why the chlorine is negative?
Yes.
Okay, I heard 1 person, but I need to hear everybody saying,
Yes.
yes, I understand. That's 2 people. I haven't heard a voice. Cameron, Mark, Chastity. Do you understand why the sodium has a positive charge and chlorine has the negative charge?
You.
Do you know or not?
I said nah.
Oh, you said no. Oh,
Yeah.
okay, I will repeat it. Please pay attention now. Anybody else didn't understand? Anybody else don't know why sodium is a positive ion here while chlorine is a negative ion? Anyone knows? Anyone didn't understand? Okay, so for Chastity, and remember that sodium gave 1 electron, so sodium gave 1 negative particle to chlorine. That makes chlorine a negative ion now because it has more electrons than protons. At first, it was just chlorine, neutral, no charge. But now that chlorine received 1 electron, chlorine becomes negatively charged by 1. That's why we have 1 negative or just negative. Sodium in this case, because it gave 1 electron, the charge that electrons have is negative. So sodium got rid of 1 negative charge. That makes it positive. Because at first sodium had 11 protons and 11 electrons, but now it only has 10 electrons. That makes that we have 1 extra proton over the electrons that we have here. That's why we have 1 positive here, or just positive. Okay? Is that clear now, Chastity?
Right. So you mean to tell me it became positive because it gave away a negative electron?
Exactly. That's what I said.
Just wanted to make sure.
Okay, no problem. No problem. If anybody doesn't understand something while I'm explaining, please let me know, because I'll believe that everybody understands if no one tells me anything. Okay, and if you feel shy about asking questions, you can just type it on the private chat and I will just express it. I will just repeat it for you. I mean, for everybody, but I will not say that, oh, look at this, it's Charlize asking questions. No, I wouldn't say that. I might say the initial and the ending, but that's it. All right, the same thing happens here. Now, which one do you think is going to be the positive ion? Remember now, this is no longer an atom. This is now an ion, a positive ion, and this is a negative ion, remember. Now, which one do you think is going to be the positive one here? The hydrogen that received the electron or lithium that gave the electron? Which one is going to be the positive? Which one is going to be the negative? Talk to me. Which one do you think is going to be the positive? I'm sorry?
Lithium will be the positive one.
That is correct. So lithium is going to be the positive, the plus sign here. And hydrogen is going to be the minus sign here. Now, these ions have a name. All the positive ions have a name. You can refer to the positive ions as cations, okay? And the negative ions are called anion, all right? An ion is an ion that has a negative charge, and cation is the one that has a positive charge, all right? Now, let me tell you something very important. You can make some predictions on what is going to happen between two elements that you combine. The elements that are non-metals, the non-metals always receive electrons. The metals always give electrons away. Notice that I wrote this on purpose in green for you to see. I put the metals here in green. Lithium is a metal, sodium is a metal. I draw them in green for you to have it more visual. Metals always donate electrons. They want to get rid of electrons because for them it's easier to get 8 by releasing the few electrons that they have in their last energy level. And then they get with this, they stay with the second to last that always have 8 electrons, all right? That's what they do. They stay with the second to last that always have 8 valence electrons. It doesn't matter which element you have, the second to last will always have 8 electrons. If you want, you can confirm that later, but even the ones that have 40 electrons, the second to last will always have 8 electrons. So for the metals, that's what I'm talking about, okay? For the metals, they will always donate electrons, while the non-metals like chlorine, hydrogen, carbon, sulfur, oxygen, they will always accept electrons. So let me ask you quickly, what do you think iron is going to do? Iron will donate or accept electrons? Iron.
Donate electrons.
Will donate electrons since it's a metal. Now you have to pull up a periodic table quickly. We have only 5 minutes before this meeting ends, and then you join me back one time immediately. Give me one example of an element that accepts electron other than chlorine and hydrogen that I have here. Can anybody give me one example of any element that accepts electron?
Oxygen.
Oxygen, that is correct. Anybody else? Examples of elements that accept electron? Anyone else?
Carbon.
Carbon. Anybody give me an example of an element that donates electrons other than lithium, sodium, and iron? Elements that donate electrons. Examples, please.
Helium.
Helium is a non-metal. Therefore, it accepts electron. Until I tell you the next thing.
Oh, you said never mind.
Okay. Now, I said that helium accepts electron, but the truth is that they don't. I mean, helium atoms don't accept electrons. And the same thing I have to say about the noble gases. If you look at the electron configuration that you did for argon, for example, argon is 18. I'm gonna do it here quickly. Argon is 18. If you do the electron configuration for argon, you have 1s2, 2s2, p6, and then 3s2, p6, 18. Notice that argon has 8 electrons in the outermost energy level. Therefore, argon is a stable element. That's why it's considered a noble gas, because it's happy. It has achieved the octet rule naturally. And the same thing you can say about helium. Helium has 2 electrons in the outermost energy level, so it reached the duet rule. It's one of the small elements, and it has 2 in the outermost energy level, so it's stable. Argon has 8, neon has 8, krypton has 8, and as long as an element has 8 electrons in the outermost energy level, in the natural state, is a noble gas. Argon is a noble gas because it doesn't need to give electrons away or to accept electrons. It's already stable. It's already full. It's happy. It has the happy number. For the atoms, the happy number is 8. So argon is a noble gas. So you can't form compounds with it, because it wouldn't donate electrons and it wouldn't accept electrons. All right, keep that in mind. Okay, so remember again, non-metals receive electrons, metals give electrons away. That's why, let me mention something quickly to you. Metals are used to make wires, because you need something that is able to give electrons. Electricity is just a bunch of electrons running through a conductor. In this case, the metals are conductors because they give electrons away. They give electrons to the devices that you have. They give electrons to the cell phone battery. They give electrons to the laptop. They give electrons to the lamp. They give electrons to the fridge. To any electronic device, wires give electrons to them. They don't give their own electrons. They just, you have to connect it to an outlet, to an electrical source. And the electrons that come to the wire from that source, they will not take them. They will just give them away. They will just let them pass through them. And that's what we know as conductivity. Substances, materials that allowed electrons to go through them without holding them. That wouldn't happen with the non-metals, because non-metals want to hold electrons. They want to keep electrons. They want to grab electrons. Okay. All right. Because the meeting ends in less than a minute, I'm going to stop the recording. I'm going to stop the meeting right now, and I will ask you to join me back one time. So I'll see you back in a minute.